confused that it's qualitative, but it's not qualitative. It's quantitative data analysis. This is a follow-up seminar from 2 weeks ago seminar on theory on quantitative data analysis. So Dr. Ongala will take us through the practicals of quantitative data analysis. Dr. Ongala, the floor is yours. You have 2 hours from 9 o'clock to 11 o'clock. How you use the time, it's up to you. But I'm handing over to you now.
Thank you very much, Doc, and good morning, everyone who is online. Welcome again for this follow-up seminar. I'd requested Doc to just have another seminar because this is one of the sessions that I believe most of you will really appreciate and pick up something that they can use in their research. If you can recall, for those who are who attended the first seminar, we went through the theory aspect, and I believe now we have an understanding of what quantitative data is. And this one is you can really make this quantitative data analysis possible by the use of statistical software. And we did mention several software that you can think about. But if you can recall, I mentioned that SPSS is one of the software which is very, very common in social research. And therefore, I recommended to give a presentation on practical aspects on how to go about quantitative data analysis in SPSS. And therefore, in this session, we are going to look at the quantitative data in SPSS. Once again, I'm a senior lecturer here at NUST at the Department of Mathematics and Statistics. I am a researcher, also a trainer. I do a lot of training to postgraduate research students, client-based research where client walk in to get advisories from me. And at the same time, I do collaborative research among other research that can come by. So that is really my area of working. At the same time, I also run a statistical consultancy firm. This is a firm that's based in Kenya, though it cut across the borders of Kenya. It has consulted on different activities to different clients, both face-to-face, online, and so forth. Last year we had very good training on qualitative data analysis, and you can find them in my YouTube. I hope maybe I can share my YouTube on the chat session, my YouTube link on the chat session after this discussion. Some of the activities that are done and the statistical consultancy unit firm, my firm there is listed in this flyer here. We do several activities that are touching on statistics, that is ranging from data analysis, forecasting and estimation, statistical modeling, survey and experimental designs. If you want to design your survey, you want to design your experiments, we can help in that. Data mining. Now we are talking of the big data. We are really into that. We are also doing some sort of quantitative analytics and software support up to monitoring and evaluation. So those are some of the activities that if you are interested in any of those, you can always contact me on the email address that is attached there. Yes, for today's discussion, we are going to look at multiple response analysis. And then this is one part that I didn't tackle. It is actually it's a theory part, but I'm going to discuss it in the practical part. So it's important that we understand what a multiple response questions are before we get into SPSS. Yes, again, we're going to look at the practical quantitative and data analysis in SPSS, and under that, I'm going to take you through a brief overview of what SPSS software is. Some of you might be seeing this, will be seeing this for the first time. Some of you, I believe, they have interacted with it, though they might be having difficulties here and there on how to maneuver through the program. I'm going to also take you through on the data entry, right? What happens when you have your data in your questionnaires and you want to put them in SPSS or key them in SPSS? What steps do you take and how do you go about it? Yes, again, we're going to look at the data entry for multiple responses. The reason why I'm really zeroing in this is a very common problem in social research. You end up with multiple responses, but analyzing them becomes a problem. So I'm going to take you through that. I'm also going to take you through some exploratory data analysis where we have the graphics and frequencies. And of course, it's going to come along on how to interpret them and so forth. We are also going to look at cross tabulations. And again, under that, we'll be looking at the chi-square tests. And then t-test. I'm not very sure whether I will be able to have some good time again to extend to regression analysis, logistic regression analysis, and so forth. But in case we'll not again be able to reach there, if there is need, I think through Doc here, he might organize another seminar for another advanced level, because especially this is a very, very vast program that you can do a lot and attain a lot in this particular program here. But again, for those who might want higher level of analysis, maybe they can follow through. Follow up later with me to see if we can specialize, if we can organize some specialized trainings on those particular areas. But again, as I mentioned, I'm still available always. Doc here can just knock my door and I will be ready to give any other more seminars that you may wish that I deliver. Okay, so yes, so what is multiple response in SPSS? In some situation, whenever you are designing your questionnaire, you might end up having questions that requires a respondent to give 2 or 3 answers. For example, I have this questionnaire, question here. The question here is, reads, which of the following sports shoes brands are your favorite? Multiple choices allowed. Somebody can easily talk of, say, I like Adidas and Nike. Somebody can talk of Adidas, Lotto, and Fila, Puma, Lotto, Clark, and so forth. So somebody can easily end up with 2 or more responses, and that's what we call multiple response. Multiple responses. So we are going to see how do we analyze this kind of questions. I know so many researchers who might really be having deficiency in analyzing these particular responses. They always want to restrict the respondent to just only pick one. Just pick one. In fact, they can draft their question in a way that only leads to one particular choice. But sometimes it's good to look at what does the respondent feel. Give him variety of options. If you can choose more, then why not just leave them to choose more and then engage such in analysis and then see how you can run that through. Okay. So in this kind of, if you are to collect this response from 20 respondents, you are likely to end up with the questions like, response like this. Respondent number 1 told you it is Adidas, Fila. Respondent number 2 told you it is Adidas, Clark, Puma. Respondent number 4 told you it is Nike, Lotto, Puma, and so forth. The person number 13 almost liked everything. So how do you end up with saying that which particular brand is most is more favorite, is more popular to your respondents, for example? How will you really get that? Assuming you are having more than 1,000 respondents, will you be able to identify that it is Fila, it is Puma, it is Adidas, which is mostly popular among your respondents? So that is actually what multiple responses will always do. Okay, so please, Doc, there are some people waiting on the, I think in the lobby. You will always, I'm seeing the notification from my end. In case they are waiting, please let them in.
Sure.
Okay, good. So I think now let's get to the practical aspects in SPSS. Last time, SPSS, I mentioned it is the statistical package for social scientists. That's what it stands for, statistical package for social scientists. At the moment, as we speak, we have version 27. And these versions always come, as they invent new techniques, new things, new features, they update, and then they release new versions. These new versions, when they're released, actually they are released based on very high-end, modern, and high-tech statistical techniques that you might not necessarily even need. Sometimes your work just needs version 12, for example. It doesn't really matter so much the version, but it depends on what kind of work are you dealing with. Your work could only need even version 5, for example. It does not need version 27. And by the way, for most of researchers, when you give them SPSS version 24 and version 27 and the version 20, they may not even differentiate which one is which based on the results which they are giving. But of course, version 27 has got more functionalities than the lower version. And of course, with the bugs that are always arising in analysis, they're always taken care of when the new versions are released. Okay, so I will exit this PowerPoint screen, then I go to SPSS screen. Okay, sure. I think okay, so before I get there, I want to I hope you're able to see my screen. Are you able to?
No.
Okay.
No.
I'll sort it out in a minute. Let me share window. I think I shared the screen last time. Share. Okay. Doc, I don't know. I'm not able to share. I don't know what is it's telling me that when I click share, it's not responding. I don't know. But you're able to hear my voice, right?
Yes.
Okay. I think it is back. Okay. It's back. Thank you. Okay. Are you now able to see my screen? I believe so.
Yes.
Good. So when you are in your desktop, you will see something like this icon. This icon here, the icon that's looking like summation sigma, this icon here. For the higher versions from version 18 onwards, they use this version, they use this icon for sigma to be used, I mean, for SPSS. From version 18 onwards, they use this one. From version 17 downwards, they use a different different icon. So if you see this particular icon tells you is SPSS, and then down there, of course, it will guide you the name of the software which you are focusing on. So when you open, the first time when you open, I just want to close what I've opened here first, so that you see what happens when you open it for the first time. Whenever I deliver this course, sometimes students tell me, I can't see anything. So let me just open it, then you see what happens when, yes. At first, you get that information just to give you some alert whether you are using the right software or you are using a pirated software. You know, some people, they use pirated software. So when you do that, they'll tell you at the point of opening. When you open, it will give you this welcoming window, the one I'm moving here. I believe you can see from your end, the one I'm shaking. Yeah, so here, if you had already opened some data sets, I mean, some files before, you can easily get them from here. Recent files, you'll see them here. So sometimes you're working, power goes off, or you're working, you save, you go to sleep, you wake up again. You don't need to search again, search your documents right from inside your files. You just need to come to the recent files, and then you get them from this list here. You'll find them listed here. They can always list up to 10. So the last 10 files that you'll have opened recently will be listed here. So you just click and then you move on. Otherwise, for those who are learning, you can also look at sample files. There are sample files that you can make use of here to help you in training, or when you want to learn on how to make use of SPSS and so forth. You can easily find so many data sets here. There are so many that can help you learn and train yourself in SPSS. So you can choose any and work on them. Once you choose, of course, you just click open and then it will open. But if you are opening SPSS for the first time, for many of you who will be installing SPSS in their laptop for the first time, you might as well tell SPSS that next time I want to open, don't show me this. But I don't think that is recommended, because you will always need it to quickly get into the files that you want to access. So I'll just close this one for now. Now, when you open, you'll see two screens. This is one of the things that always sometimes my students ask me, oh, which I'm seeing something different from what you're getting there. So you'll see two screens. One screen is called output. Just read here. It's called output screen. So all the outputs that you'll be running in SPSS, or any communication that you'll be getting from the software, will be published in output document here. So when you open, two files will pop up: the output file and the data editor file. The one at the background here, this one here, is the data editor file. This is where you have your data. At the output, this output file window is where you have your output, and any other communications, warnings, everything, you get them in the output here. So when you want to feed in your data, you start with the data editor. Okay, so temporarily, I'll just minimize this. Even if you close it, it will open itself whenever you open your you have any information to be communicated to you by their software. Good. So in this data editor, this is where you enter your data. And from the data editor here, you can see it is made up of spreadsheet, columns, and rows. These columns here are variables. Variables, I believe you can remember last time when you were talking of variables in our presentation. Variable is one particular quantity or one particular phenomenon being measured from from an object. For example, age can be a variable, height can be a variable, and so forth. Now, on the rows, we have different rows: row 1, row 2, row 3. These ones are cases. Sorry, they are called cases. They correspond to the respondent. So row 1 correspond to respondent number 1. So if you pick the first questionnaire, all that questionnaire must go in row 1. All that questionnaire must go in row 1. That's the unit of analysis. All that questionnaire, even if it is 100 pages questionnaire, it must go through row 1. If you get the second questionnaire, it goes through row 2. Third questionnaire, it goes through row 3, and so forth up to the last one. There are so many rows that you can, SPSS has provided you with so many rows that you can enter here. More than 50,000 rows, so many. And the variables, number of variables are also so many. You can have so many variables that you can design. You can have, if you have so many variables in your questionnaire, you can easily have all of them in SPSS. It provides for that. Okay, good. So number 2, in this editor here, you will see the usual menus, file menus is usual. The way you use Word, Excel, and blah blah blah, all those other software in the same way you use them here in SPSS. You have new, if you want new editor. If you want new editor, you can get it from here. Actually, it will show you. If you want a data editor, what you're seeing on the screen is called the data editor. If you want syntax, syntax is when you want to run SPSS based on commands. I don't want to take you there. Only for those who are interested in programming in SPSS can get that. So that means you can run SPSS with just command alone without necessarily click and drag. Then, if you want new output, also you can get in the under the file new and so forth. So we have so many other functions that you can get under that menu. Now, interestingly, I want to mention something on import data. Sometimes you have data which is in other programs like other databases like Excel. If you have your data sets in Excel, you can easily import them to SPSS. You don't necessarily need to key them one by one. And I think this one is important that I mentioned because some of you might want to collect their data using online platform, things like ODK and Kobo, or some Monkey Survey. Those software, data collection software, they enable you to go to the field with just your phone, and then tap in the responses. Once you tap in the responses, these responses that are captured already in the data in the what do you call, in the database, and then in the database they are coming in as Excel. So once they're in Excel, you will escape the expense of the data entry. You want to make the data entry. There'll be no aspect of converting your data from paperwork to SPSS. You just import them from Excel to SPSS straight away without necessarily wasting time or making more errors. So I do still encourage you also to start thinking of, if you are going to do your research, start thinking of digitized data collection. It is fast, quick, and convenient and accurate. Okay, so that is this is where you will make use of import data if your data set is already in other spreadsheets, and you can as well import them from SAS, you can import them from Stata, you can import them from DBase, you can import them from any other spreadsheet platforms. Okay. The same thing I also want to mention, which is also very, very important. You can also do export. You can also export data. Once you have your data in SPSS and you want to send it maybe to your client or to somebody who is not having SPSS, is only having Excel, you can export them as Excel or as CSV data, and then the other person on the other side can easily see your data in Excel or in a CSV form or any other form that you may wish. So that one is also possible. So it is not necessarily that you must send your data in SPSS. You can still send them in other forms after exporting them to those formats. Okay, the rest I think are repetitions from what you have in other software, Word, Excel, or any other software that you might have in your computer. Under edit, in the same scenario, we have the similar things that you always have in other software, but in addition, there are two important functionalities under edit, that is insert variable and insert case. For example, I have a variable stated here as variable 1. Let me just say variable var1. Let me just say there var1. Okay. So assuming I'm having var1 and var5, and I realize that there is a variable that I want to insert between var5 and var1, for example. So that is where editor here comes in. Edit insert variable comes in here. The same thing can also happen when you are inserting your cases. The same thing you can use under edit. Under view, this is also the same, similar to what you are seeing in other software. But again, I'm going to make use of this menu when we will be having already some existing data in our spreadsheet here. But again, focus more on value labels. I'm going to talk about more on value labels here, so that I tell you what really it does. The rest really is similar to what you see in other software. Then we have data menu. This is very important now. This is where you manipulate, you use to manage your data, not manipulation, managing your data. Like when you want to define variable properties, you want to set measurement levels for a known, you want to copy data properties, you want to define date and time, you want to define multiple response sets, and so forth. You proceed like that until you get to weight cases and so forth. Split file, sampling are also found within this data menu. Then we have transform. The transform here is still on data management and manipulation. For example, in one of the questions that you asked in your questionnaire was that when were you born? Which year were you born? Somebody says 1950, 1967, 1980, 1990. But in your analysis, you want a variable called age. You do not want the year of birth. Okay, you can make use of transform to get the age, because already you will just have the year of birth, just subtract from the current year, and then you get the age. So doing that manipulation, it's what we call transforming your data. Transforming your data is shaping your data to a form that you want. This column here is going to help you in transforming transforming that data which you are having. Now, there are two important menus that you are going to make use of in analysis. That is analyze menu and graph menu. These two menus are going to be handy when now you already have your data and you are now in the analysis. You're going to make use of analyze and graph. Graphs, it will give you the different types of graphs. You must understand what type of graph do you want and what type of graph can really fit to particular data which you're having. Not all graphs are going to be used for all the problems which you have. Different problems have got different types of graphs to be used. You can't use line graphs on a variable like gender, for example. So these graphs, you must understand which graphs must I use for which particular problem which I want to show. And then analyze, here is where you get your analysis procedures. When you want to do your descriptive analysis, Bayesian statistics, tables, compare means, blah, 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 it goes through up to direct marketing. There are so many functionalities that you can see in this list here. Some of them are very complex, requires a lot of statistical understanding. Some of them are meant for modeling, and I believe SPSS is really doing a good job nowadays. If you look at version 19, it didn't have all this number of functionalities which we are now having in version 28. So version 28 is really, really versatile and robust. So you can easily see a lot of things you can do in SPSS here. Okay. These ones are meant for SPSS gurus. If you want to just change the appearance of your SPSS, the way you want it to look like, the way you want this to do things, you can make use of extensions. But I advise you, if the basic soft SPSS that opens when you open SPSS is just enough for you to do run your stuff. Leave this one for the programmers and so forth. Windows, window menu is just helping you to manage your windows. If you want to see your windows side by side, for example, splitting windows side by side, like now I'm having the whole of my window has been split in 4. I have this part here, I have this part here, I have this part here, I have this part here. But of course, this one helps you when you have so many variables and you want to move through different variables and so forth. So you see, that one helps you very easily to just have a close view of everything you have in your SPSS window. Now, for those who are still learning as you here, you can really make use of help. It has a lot of materials here that you can really make use of. It has so many materials here that you can really make use of. I advise you that you find time and go through that particular, this particular functionalities. It will give you all the questions that you might think about. They are all here in help. Good. So assume now you have your questionnaire. You have your questionnaire. This is the questionnaire. You have, in most cases, it is good to start thinking of your analysis before you go to the field. Don't come with the data and is when you want to start running with you start thinking of how do you analyze. The how to analyze should be at the conception of your research. How am I going to analyze these particular questions? It should come before you are in the field. Otherwise, you might end up coming with a lot of junk data that are not necessarily going to be useful to you. So think of field analysis before you go to the field. Number one thing, there is this as one tip that I want to give you in designing your questionnaire. It is always good to indicate a questionnaire number whenever you want to run an analysis from your questionnaires data. Provide a space for writing your questionnaire number. This is going to help you to trace which questionnaire you are dealing with, or if there is some problem at some point of your data, then you can just locate which questionnaire it is, and then you can easily get it from, trace it back from the hard copy. So questionnaire number here is very, very important. For those who might want to do paper data collection, as I mentioned, I'm trying to convince you to run away from paper collection, go digital. So if you go digital, then this will not apply. If you are on paper questionnaire, of which some might still want to go by, then try to include this field here called survey number, or just questionnaire number. It's going to really help you in tracing back your questionnaires. So assume this is a very simple questionnaire I'm having here, and I want to enter this questionnaire in SPSS. How do I start, or where do I start? I'm going to show my screen side by side just to enable us work on both of them. I'm going to have this one here. Then I'm going to have my SPSS here. Are you able to see my SPSS and my questionnaire?
Yes.
Good. Now, let me just remove this other variables which I had created here. Okay, I believe I'll explain what I'm doing. I'm just clearing out the variables. Now, in SPSS, there are two, if you are on data editor, there are two tabs down here. One tab is data view, the other tab is variable view. There are two tabs. Whenever you click the variable view, something else comes. The vars which are being seen on the data editor disappears. When you are on data view, then you see the vars. Now, data view is the tab that contains where you can see your data now, the actual data. Now, on this data view, I want you to look at my column heads. They are all written var. They are faint. You can see they are all faint. But when I add a variable, for example, if I add a variable, you can see now the first column is called var1. It is now more darker. It means that is the variable. I have only one variable in this data editor. Now, how do I pick my variables? How do I pick my variables? How do I know my variables from my questionnaire? As we mentioned, each and every row here is a questionnaire. So all of this row is going to be one of this response. So in this questionnaire, okay. Okay, let me, I want the pen. Okay, good. So in this questionnaire here, sorry. This one is a variable, it on its own. I can call it var1. This questionnaire number. And this var1 here, I can give it a name, questionnaire number. Okay, that is the first variable in this particular questionnaire. My second variable where the response comes in is this variable here, where I get a response. This is a variable. This variable here, I will call it variable age. Okay, And this variable is the third variable. I will call it variable gender. And this variable here, I will call it education. I can call it educ. So let's have those three. Sorry, we call it educ. Educ with C. Okay, let's have those four. How do we prepare data entry screen for that particular questionnaire with those variables which I've just mentioned? Now, my first variable is called QNO, that is questionnaire number. I want this first column to read QNO. So for I to do that, I come to variable view. Then in this variable view, there are so many different columns here. The first column is telling you to give the name of the variable. This is where you define your variables. All the variables, you define them on the variable view. Now, under name, you type the name of the variable that you want. In our case, the name of the variable that we want here is QNO. QNO. Now, in the variable view also, you are given an opportunity to describe the data type of that particular. What type of variable is that? Is it numeric? Is it date time? Is it string? Is it what? And so forth. So what response are we likely to get in this variable here? Of course, you'll get response like questionnaire number 1, questionnaire number 2, questionnaire number 3, questionnaire number 4, questionnaire number 5, questionnaire number 5, and number 6, number 7, like that, up to questionnaire number n, for example. So it means the way you look at them as numbers. These are 001, 002, 003, and so forth. Now, my question is this variable a numeric or non-numeric? That's the question. Can somebody figure out for me? Is it numeric or non-numeric? Remember, the response that you get from here is 001, 002, 003, 4 up to 1,000, depending on how many questionnaires you have. Is it going to be a numeric or non-numeric?
The numeric variable.
Okay, good. So that's why I wanted to make this statement, and I want it to be very, very clear to you. You do not give a variable numeric status because of the response you are seeing. You only give a variable numeric status depending on what that variable is saying. What is that variable? Is it really a numeric? You can be seeing numerical entries in that particular variable, but they are not numeric. Now, a numerical variable is a variable that has got values. The numerics must have values. There has to be a value to that numerical entry that you are seeing in that variable. If they don't have values, then it is not a numerical variable. Now, what do I mean with value? If I have questionnaire number 1 and questionnaire number 2, that is 1 and 2. If I add 1 plus 2, I should get 3. Is that right? Now, if that situation is possible, such that I pick observation number 1 and I add observation number 2 and I get 3, and this 3 is having a meaningful information, then those numbers have got values. Now, let me take you back now to our questionnaire numbers. I have 001. If you add 001 and 002, of course, it is 1 plus 2, you get 3. Is the 3 that you have gotten really having a meaningful information? The answer is no, because here what I'm doing, I'm taking questionnaire number 1 and questionnaire number 2 And then from my calculation, number 3. That is not true. You take question number 1, add question number 2. Do you get question number 3? The answer is not true. So in that case, then those numbers I am seeing under questionnaire number are not numerics. They are not numbers. They are called labels.
Got it.
Okay? So don't always just have numbers, because once you have them numbers, SPSS will treat them as numbers, and it will want to analyze them as numbers. So even if you want to run some graphs, it will give you graphs for numbers, not graphs for non-numbers. So questionnaire number here is not numeric. It's a string. All labels are strings. Okay. Now it is a string with what width? Width is the number of characters that are going to appear in that particular variable. For example, in my case is 001. If I'm only expecting up to 999, then I can use 001. The maximum elements I can see is 3. Maybe you are talking of questionnaires up to 10,000. So it means the number of digits I should be getting in that particular variables are 1, 2, 3, 4, 5. So here I will put 5. So depending on how many entries, how many characters you want in that particular variable. So if you put 5, it means you can only accept up to 5 characters. I don't need decimals in strings. Now labels, and I want you to get this one very clearly also. Labels and name, they go together. Name is a shorthand for the variable that you are referring to. Like QNO, who will know what QNO is? If you are presenting this and you gave somebody this data set, who will know what QNO is? Very few will know what QNO is. And therefore, you need to give a statement explaining what QNO is. And when you run your analysis, you will only see the output of what you explain, not the name, not the shorthand. But if you don't give a label, you'll only see the shorthand. And this is going to help you when you are sharing your data with somebody else, or at analysis, you can easily see what particular variable is all about. So like in this case, QNO means questionnaire number. So in the label here, I will just come and say questionnaire number. So somebody will see that whenever I have QNO, it means questionnaire number. So if you analyze this, what you will see in your output is questionnaire number, not QNO. So it is important that you specify the questionnaire, the label for every variable. Okay, so yes, for values, for this particular variable, I will not explain what values are. I'm going to explain it in the third variable. So keep it, just pass it. The same as missing. Sometimes you go to the field and you find that a respondent is not able to answer you on particular questions. These are always called missing values or missing responses. If you don't enter anything in the data view, then SPSS will treat them as missing. Sometimes as an analyst, you might want to define your own missing, that if somebody enters something like 9 or something like 20 or something like 30, I will treat it as missing. That is when you come and define it here. Okay. So if you don't define it, it will be system defined, no missing. But if I define it myself, if I say that I want particular values, for example, I want 9. Okay. Anytime somebody enters 9, then I treat it as missing. Then SPSS will treat it as missing. Sometimes you are collecting data about university students who are below 50 years old, for example. You are collecting data among university students below 50 years old. Okay, and then you happen to find a questionnaire giving an age like 70, for example. It means that particular respondent was not supposed to be amongst your sample, and therefore you need to remove it out. So what happens? You might want to remove only that particular entry for the age, but you leave the rest because the rest might still give us other information. But of course, once you find that kind of entry, the whole if your criterion for picking your sample was between 20 to 50, then somebody who is age 70 or 65 should not be in that kind of research or sample. But sometimes some entries are done by mistake, and you realize that somebody has just entered 65. Now, how do you want to treat this kind of values if you are sure that this 65 was actually the true value that was picked in the field? Then you can ask SPSS that whenever you find a value between 50 and 100, that's where you come now and set them in the range here. I don't know why it's not active. Why is it not active? Why is it? No, it's not active. Oh, okay. Yeah, I'm not sure why it's not active, but I need to find out why mine is not active. It should be active. Then you specify the range, low 50, high 100. If you specify that, then you are going to get a value that SPSS will reject or put as missing. Oh, I know why it's not picking the range values, because I stated that this variable is string, so and therefore it cannot pick any values as missing as ranged values there. So if I put it as value, it will show me that it will activate that particular button. But for example, if you put 50 to 100, so any value that is more than 50 will be treated as missing. So only that particular cell will be treated as missing. The rest of the cells in that particular case will still be held in your set of data. Okay. Column width, you can also state your column width here. If you want a column width, of course, column width go in tandem with the width of number of items, number of characters. If you put here 8, you can't have column width of, items of 5, and then in the column width you say 3. It means the 5 will not fit. It will be entered, but it will be squashed. You won't see more part of your data set, but of course you can always drag and drag up and down to reduce or increase your column. So this is just for visual on your data set. Then alignment, if you want to align it in left, right, center, something like that, you can also see that. So the next thing is measure. What is a measure? Measurement scale. I believe some of you must have learned this in your statistics class. Measurement scale. We have nominal scale. We have ordinal scale, ratio, and interval. Nominal scale, and of course, this is very, very key. Ensure that you specify this particular column here for measure. State the measure of your variable that you are working on. Otherwise, you're going to end up with you might miss out some functionalities when it comes to when analyzing your data. Now, nominal scale are those variables whose responses cannot be put in any order. Actually, they are non-numeric, first of all, non-numeric variables which cannot be put in any order. And I want to give an example. Male and female, male, female, like this particular variable here. Somebody can write that my responses are either male or female. Somebody else can say it is F or M. Somebody else can, yeah, like that. So it doesn't matter which one starts. The order does not matter here. Such kind of variables are called nominal measure scale. And therefore, it is important for you to state that. Otherwise, if you don't state it, you are going to be in problems whenever you are doing analysis now. Now, other example that you can talk about, like religion, for example. Let me have now a situation where we have 3. Christian. Use a different color so that you can easily see. Christian, Hindu, Muslim. For example, we have these 3 possible observations, possible responses under faith, religion, for example. If I start with Christian, does not mean that Christian is the one that must start. There's no order here. I can start with the Muslims, then I go to Hindu, then I go to Christian, or I start with the Hindu, then I go to Muslim, then Christian, like that. There's no order here. So that is what we call nominal. So if your variable is going to be nominal, please, you must state it. Now, apart from nominal, can we have some other variables which can have some kind of order? For example, look at the third question here. What is your highest level of education? We have pre-primary, primary, secondary, and tertiary. Of course, this one can be put in order. If I start with this one as number 1, this is number 2, this is number 3, this is number 4. There's some order there. Now, the way we analyze this question and this question are different because they are of different measure. Okay. Now, if I start with tertiary number 1, then this will be number 2, number 3, then number 4. There's that order. So once you have superiority order, then it goes beyond nominal scale, it goes to ordinal scale, and therefore you must state that in your data entry screen. Okay, ordinal here, you can also have ratio and interval. Ratio and interval, they are, for those which are ratio and interval, one, they must possess the ordinal aspect. For example, age. Age, somebody can say 20, 27, 13, 14, for example. Of course, you can order that one. You can say we have 13, we have 14, we have 20, and we have 27. There's some order, 1, 2, 3, 4. So it means they possess this property here. But in addition, you can easily manipulate these ages here. You can find the average age here, and it makes some mathematical sense. And in that situation whereby you can make some mathematical sense out of the manipulation of your ordinal values, then it goes beyond ordinal. It goes to ratio. So this age is not ordinal, it's beyond ordinal. Yes, it possesses the aspect of ordinal. You can analyze it based on ordinality, but there is a more superior measure scale for it, which is called ratio. You can do more beyond the ordinal aspect, and therefore you need to specify that here. Here you can see in SPSS we have only 2. We have nominal and ordinal. So all these values that we're having here, they are in SPSS, they are called ordinal. So what will separate the ordinal that I'm explaining and the ratio and the interval is based on what type of data did you mention here? Was it a string or was it numeric? If it's numeric, then it will pick the ratio scale and interval. If it is a string, but you specify ordinal here, then it's just going to be an ordinal scale. Please find time to equip yourself with that. Then role input, that one, it just tell you what are you supposed to be doing on this variable. I should be doing some input of data. Target, if you are not going to input, but it's just going to refer to that particular variable. It's just hanging, but you don't do anything on it. you refer to it, but you don't enter anything. In most cases, it enters data on its own. Then you must specify that. But in most cases, you will be creating screens to input the data. So I would advise that you let it the default one input. Okay, so that is what happens. I think I've explained all of the characteristics of your variables, and I believe it will now be easier for us to enter now the second variable. Second variable now is going to be age. Age is numeric, and I want age maybe with the no decimal place, and then age of the respondents. That's the label, age of the respondent. Okay, then values. I don't need to specify values still. I passed this one, so I will come back to it. Then I only want age. I only want age which are now look at this now. Look at this now. I have started numeric. Now when I come to missing, I can now easily check this box which was giving me a problem because of the fact that it's now numeric. Now here I want to specify values like 50. If I get 50 to 100, for example, that SPSS will treat it as missing. SPSS will treat it as missing. So any value that is ranging between 50 and 100 is going to be missing. That's an example. Somebody else can say, if I get a value like 90, a value like 90, I need to remove this one. Oh, sorry. I need to specify there. I'm sorry. I need to specify there. So if I get a value like 90, for example, for discrete, I will be able to it will be only be looking at the value 90, and then when it finds the value 90, it's going to be treated as a missing value. I'll explain what column is. Right align, or of course, whenever you use numeric, it will automatically go to right align, so it comes automatically. Then measure, I need to look at that now. If I specify numeric, measure, now I have the third measure now is coming up there. Remember, I can put nominal, I can put ordinal, and again I can even put scale. Scale is now where we have the ratio. Ratio and interval here gives you scale. In the previous one, I cannot get scale because it was just string, and therefore you can only choose ordinal and nominal. So these particular specifications are very, very key when it comes to specifying your variables. And if you don't do that, you might end up running your analysis without necessarily getting the right things. Good. So the third one is going to be gender. So let me just say gender. Gender is a string because from what I'm seeing is just male and female is a string. It's not numeric. Then I here will just say gender of the respondent. Then under values now, remember the values I'm supposed to be expecting respondents to either tell me it's a male or it's a female. Now, where you have two particular options or three options, that is where you can now specify the values. These values you are seeing here, the male and female, you can now specify them under values. Remember, for my age and the questionnaire number, we don't have particular values which we are going to restrict our respondents from giving us. But for question number 2, we have male and female. It is only male and female and nothing else. We can specify the value so that in case there's any other response that is given, SPSS will not accept. So I specify values here. Now, if I click, I hope you saw what I click. There are some 3 dots. When I click on that cell, there are some 3 dots at the end of the cell. If you click on it, it brings you this particular small window, then it gives you something blank. You might be wondering, what do I do here? Just add. There's a plus here. Just add something. Now, I want always that when I enter the value 1, the label of that one should be male. Then add another one. When I enter 2, the value for that value is 2, female. I mean, is female. Now you see, SPSS will read it as 1 and 2, but this one, whenever it finds 1, it will mean a male. Whenever it finds 2, it will mean a female. So this 1 and 2 are not having value as per se. They are just marking the particular labels which you are having there for easier analysis. So once you finish, then you say, okay. Okay. Good. So the third one, which is the last one, the rest I think you can think on, or you can do on your own. That is educ. Educ also is a string. String. And then I can talk of level of education. Level of education. Level of education. The same thing happens. I will just specify. 1 is preschool. 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 2 is this is pre-primary, sorry, pre-primary. Primary, then this is primary. If I add the third one is secondary. Fourth one is tertiary. Tertiary. This is supposed to be 4 tertiary. Then I say, okay. Okay, so let's see. That is, you can do that until you finish all your variables. You are having 100 variables, 300 variables. You must ensure that you specify them here. And by the way, I needed to have specified also the measures. The measure for male is nominal. The measure for gender is nominal, and then the measure for education is ordinal. Here is ordinal. Okay, then I have that. So I have nominal, I have scale, I have nominal, and so forth. So when I go back to data view, this is what you will see. But before I go there, before I go to the data view, I want to mention something under names, the name of the variables. These names of the variables, number one condition is you must only enter one word. You cannot enter questionnaire numbers as 2 words. It must be only one word. And number 2, it must there must be no space. Of course, if you put space, you end up with 2 words. For example, if I try to enter a Duke of, it rejects. It rejects. Sometimes it's good to give a variable name that is really representing, trying to give you an idea of what the question is. This is going to help you at analysis point. For example, look at this question here, question number 5. How many employees do you have? For example, what name of variable will you put here? For example, somebody can put employees. What does employees means? You know, when you go to analysis, you will only seeing employees. You need to have that aspect, the number of it. So somebody can say no emp. You see, no emp is only me who knows what no emp is. And therefore, you need to explain, you need to really explain. That's why the label is coming in. Number 2, when somebody is only looking at the no emp thing at the analysis, might not know what this no emp is all about. So give some particular names that really indicate indicate, try to give you, insinuate the question that you are trying to refer to. For example, somebody can say that just to improve this particular variable name, you can say NO underscore off underscore. It's still allowed. Look at that. It is still allowed. So somebody can easily see that N underscore off, it means number of employees, something like that. Okay. Another thing, another technique that you can make use of, you can use the question numbers. You can say question 4 on the questionnaire, then number of employees. Just to give indication of what is that particular variable you're talking about, for example. So if I to look at question 4, I can, because when you be analyzing, you'll be having the questionnaire alongside, so you know what is it in question 4. So you can see, this is actually the most appropriate one whenever you're analyzing. Just make use of the question numbers, Q4, to mean that this is the variable coming from question 4, to give you an indication and a clear understanding of what the variable is talking about. Okay, so let's see what happens in the data view. In the data view, this is what you will see. Whatever we were trying to define in the variable view there, you can see them here now. So assuming you are entering the first questionnaire, 001, age is 13, example. Gender, I can type 1. Remember, there is an arrow which comes in there because I specified the none. You can use that arrow to specify 1 or female. Or even if I just put 1, the answer that comes up is male. If I put 2, the answer that comes up is female. The education, if I put 4, answer that comes up is tertiary. And remember, you can also as well put 5, and it doesn't give you anything. It will accept because it was a numeric. We say it was ordinal. But remember, the 5 is not part of the response. And again, you also needed to have started thinking about how do you now do away with this kind of numbers which are not appropriate in your entry. Okay, you specify them in the missing, of course. Okay, so this is 4, for example, maybe. Now, let me get you back to the column, the menu data. There's something that I wanted to come back after entering this data here. So there is a data view, I think it's in view. Yeah, in view. I mentioned about value labels. These value labels, you can see a little 1 and little a, little 1 and little a. When it is checked, when this value is checked, then you will always see the specified values on the variables as text. That is female and tertiary and so forth, not as numbers. But when it's not checked, if I remove the check, you see them as numbers 2 and 4. And therefore, whenever you want to see what the numbers represent, just come to view and then check the value labels, and then it will tell you that this particular column was defined like this and so forth. Okay, good. So that is what is for data entry. Now, one more thing on data entry is multiple data analysis. Entry. How do we define multiple data entry? Multiple response. Let me just get the questionnaire. Then we see. I think it was here. It was this one here. You have this. You can recall this questionnaire here. This questionnaire here, and we expect the respondent to be giving more than one response, like Adidas, Nike, and blah blah blah, all that. Now, in this case, what happens whenever you want to enter this, make a data entry screen for this? This is not going to be one particular variable. It means I expect I expect respondent to make a response on this. I expect a respondent to make a response on this. I expect a respondent to make a response on each and every of these choices. It means where you expect a respondent to make a response, it will make it a variable. This is going to be a variable. So assuming it was question 5. So in this question 5, I have question 5 Adidas, question 5 Nike, question 5 Clark, question 5 Lotto, question 5 Fila, question 5 Puma. All these are going to be variables now. Remember, it's different from what we had in the level of education, where respondent is only picking one and only one. So now, when it comes to this one here, you specify each and every response as a variable. So here I'll have Q5 Adidas. You know what Q5 is, and Adidas is one of the response. So I expect the respondent to say yes, I prefer this one, or no, I don't prefer this one. So it's a yes or no question. So it's a string. Preference for Adidas. For Adidas. And then on the response here, I should have either 0 for no, and then 1 for what? For yes. You see how I did that? That's the first one. Second one is going to be I want to, okay, I'll just copy this one. Question 5. Question 5. Nike is also string. Yeah, and then preference for Nike. Then yes or no. No, I can't just copy this. Just copy this and paste it here. Yeah, it's possible. Without necessarily, and they are all nominal, remember? Oh, what is coming here? Okay, good. So I can copy this, paste this one. I can call it Q5, but Clark. Okay. Paste it here. There's a reason why I'm doing all this. Just give me a moment. The next one is Q5 Lotto. Then this now it will just be Lotto, and then the other one is Fila. Q5 Fila. This is also Fila. Then Puma. Q5 Puma. Okay, good. This is going to be Puma. Okay, so and you go to that data entry screen. This is what you see. So you will realize that one question has generated over, about 6 variables. So assume the response for this particular person was the first respondent was Adidas and Fila. So how do we key in the entries? Adidas, it means Adidas, yes, 1. And Nike, no. Clark, no. Lotto, no. Fila, one. And Puma, no. That's how to deal with multiple responses in SPSS. Okay, good. So of course, analysis now will come again how to analyze this one because they were response for one particular question. How are you going to analyze them? That's also another question that we will look at, I think, in this discussion here. Good. So assume now you have your data in SPSS. You want to start manipulating them and see what they're giving you. Okay, I'm just going to open one data set which I already gotten in my data bank. Let me just open one so that we use it for our practice. I think, yes, I think this one, customer database. Yes, I have this data set here. Okay. Look at this data set is a big set of data. It's running to so many variables. So many variables. It's running to so many variables. So many variables is actually so many variables are here. So many variables, and then so many cases. So look at this one here. This particular column, customer ID, is the same as questionnaire number. Remember. And whenever you use online data collection methods, online survey methods, these are some of the costs that are always generated. Okay, so this is the similar to questionnaire numbers. They are unique across, and we have all that. It's a lot of data set that we can think about. Now, other thing, when you move your cursor to the column, to the variable name, it will give you the characteristics, the name of the variable, characteristics, and the labels. Like I've moved it to customer ID. You can now see the name is customer ID, label is customer ID, string type is string, and the measure is nominal. So those ones will be given. Like for example, if I don't know what ED is, look at this ED. I do not know what ED is. Just move your cursor on that ED, and then it will tell you ED means years of education. Sorry, years of education. So the first thing you may want to do with the data set is to run through and see some exploration, what your data is communicating. Okay, and of course it depends with the objectives which you have, but I do not have any specific objectives in mind. But I'm just going to run very run some analysis here and there, depending on what I think is best fit for your understanding. So one of the most important exploratory approach is to run your frequencies, and to run your descriptive statistics, and also graphs are very important to have a look. For example, if you look at region, you might want to find out how many were from which regions, and how many regions do we have in this set of data, because you may not be easily know that how many regions we have in here if you don't necessarily run it and get the summary of all those regions. It's good to do a frequency of all variables and see what particular aspect of things do you have in this particular set of data. For example, let me just see how many regions did we have in this particular survey, for example. So I will just use analysis, descriptive analysis, and then frequencies. Then when you come to this window comes, this small window here will appear. And then I'm interested on regions. Regions is the geographical indicator. I click on it, then I move it to the right with this arrow here under variables. then just simply just leave everything as default, then run the, say okay. If you click OK, already my data is in good shape as far as this descriptive analysis is concerned. This output is concerned. If you look at the table here, this is what we call frequency table. If you look at the title of the table, is reading geographic indicator. It's reading geographic indicator. Yet in our data editor, you are seeing region. So that's what I was saying. Whenever you specify well your label, then you're going to have a good good statements or good headings for your outputs. So this one easily tells you which geographic indicators were considered in this survey. So in this survey, I'm talking of region zone 1 up to zone 5. There is no any other zone. So it means for that particular variable, it's in good shape. And even the sampling was done quite well, because there are almost 1,000, all of them. So that one tells you the distribution of the respondents were quite well in all the regions. And therefore, you can, it's a variable that can easily give you, it's in good shape, that is. Now, in these frequency tables also, we have percentage. It as much as giving you the frequency, it also gives you the percentages. Now, what do you report as a researcher? What do you report as a researcher? Do you report frequencies or do you report percentages? Now, secret is report percentages. Avoid reporting frequencies. Now, why? Today I take a sample of 5,000. Tomorrow somebody takes a sample of 20. Another person takes a sample of 100. Another person takes a sample of 10,000, and so forth. When you are reporting, you report based on the population, on inference. And therefore, on inference, the percentage here is quite key. Now, when you are reporting percentages also, you must specify your sample size. So you can talk of my N was 5,000, like what I mean, you are seeing in the first table here. N is 5,000, and in the sample of 5,000, this is the distribution of my respondents per zone in terms of percentage. So talk of 20% of my respondents came from zone 1. Don't talk of 1,119 persons came from zone 1. That does not really make statistical sense in terms of at the level of inference. Make use of percentages. Okay. Cumulative valid percentages are used whenever there is some aspect of missing values. But if there's no missing values, you'll find that percent is the same as valid percent. So like in this case, you are having 20, 20.4, 20.4, 21.0, 21.0, all of them. They're the same. Let me do something here. Let me just do something here. Then you see what I mean. I want to remove this first one, this on one. I just want to delete it. It's missing. It's missing. So when I do frequency of this, and I do frequency of this, then see what happens now. Look at the difference of the two tables now. The first table, there was no missing system. Remember, this missing is missing system. Missing defined by the system, remember, because I did define missing there. It's picked by the system itself, right? And therefore, it's saying that one variable is having one case is missing in the data set, and therefore it reduces your stuff to your true values to 499. Okay, now look at it's so insignificant. I was expecting that the percentage here should change to 20.3 maybe, but one is so insignificant. When you take one out of 1018, it's essentially 0.001. It's quite insignificant. Therefore, you can still see it's 20.4, 20.4. So it didn't really make any significant change. And that is how beautiful, again, sample size plays a big role. Just missing one value does not really make any difference in your results. Now, but what I wanted to explain here is that when these missing values are so significant, then you will see that the variation on the valid percent. Valid percent are only computed based on existing valid entries, excluding missing values. And cumulative percentage is also computed based on the valid percents. Okay. Good. So the same thing you can do for all the categorical values, like ordinal values, like town size. Town size here. Let me see what town size. The analysis for this categorical value town size. What happens there? Let me town size. I just run that one and then see what happens. Now, look at that result. This particular variable is categorical, is non-numeric, though ordinal. And ordinal came in when we were specifying the values in the variable view. And that's why you can see the first one here is more than 250,000, followed by 50 to 249, followed by 10 to. So the way this one comes in, the way it was defined in the value levels. Let's see how the value levels was done before we come back to this particular one. And of course, it's telling us that we are having 2% missing. I mean, two values missing. So let me just see what happens in the these two particular the way these variables were specified in terms of value levels. So let me just go to variable view and then town size. Town size here it is. Look at that. Number one was specifying there is that particular order which must be followed. Number one is specifying more than 250,000. Number two is specifying 50,000 to 249,000. Number three is 10,000 to 50,000, like that up to number five, which is less than 2,500. Now, what SPSS is doing is only ordering these ones here. The numbers, the values 1, 2, 3, 4, 5. It does not see the levels. It does not order the levels. So the way you define your value levels is very, very important for ordinal aspects. Please, it's very, very important because it only orders the values which you're seeing here, 1, 2, 3, 4, 5. It does not order the levels, no. So take note of that. So the way you specify the orders are very, very important. Oh, where is it now? Okay. There's another variable here which I think is also of good interest. Now, age. Look at this age here. Can you easily run frequencies for that age? What will happen? Let's just try. I mean, doesn't really cause harm trying and see what happens so that you see what really happened when you expose your numerics to frequency tables. There you are. And this is what you get. This is the table that you're getting, the frequency tables. Age in years 18 running across up to 79. The question is this table nice enough to present? Is it good enough to present? The answer is no. Remember, the aim of analysis is to reduce the bulkiness of your data. This is still too bulky. You can't even comprehend what it is saying. You can't even understand what it is saying. Okay, and therefore, it is quite important to look at this if you want to run the frequency tables for this, you can categorize this particular variable. And that is why it was categorized here. I'll even show you how we do the category. Here, look at this one here. Instead of running frequency of age, I should run the frequency of age categories. So analysis, frequencies, frequencies, age categories of that. Let me remove this other one. Then see now what we're having. That one is much more presentable than a long table which you have in the previous one. Now, the question is, how do we do these categories? Because when you are asking respondents, you are asking them, what is your age? Do you do the categories in the field? I think that will be a tall order. SPSS can do that. Now, assume that we didn't have this column here. I think I need the output so that I can define my. I need the output. Oof. I just close it without saving. Okay, I need this output. Let me just put it here. So I want to remove these categories here. Then I create ours from the age. So I will clear this. So I do not have now age group. There's no age group now, but I need to create age group. So what do? I'm going to come here. I told you about transforming your data. I will come to transform, and then I'm going to record into a different variable. You can also as well record to the same variable, but I want to create another variable called age category, but it's based on age. So I will use this particular function here. So I click on this. Then the input variable that I want to categorize or transform is age. I move this age into this box here. And once I move it into this box, this part of the window here get activated. Then name of the new variable is age cat. I will call it age category. Age category. Then if I click change, look at the question mark. Remember, I want you to observe the question mark. If I click change, you see now the question mark has gone. Now I've gotten my new variable age category. But you must specify these categories. SPSS cannot do it for you. You must tell SPSS that this is how I want you to do the age the categories. So come here to old and new values. And I want to make use of the outputs here. Output, where is the output? Okay, okay. I think I'll just be able to, okay. Okay. I'll just be able to run through both of them side by side. I need 18 to 24. Now, here I'm specifying the ranges. On the old values, it gives you option. If you want one specific value to be transformed, you specify the value. If you want missing to be transformed, you specify the missing, but I didn't see any missing there. But me, I think I want range. The first range is 18 to 24. Then new value there will be 1. If I add, so it is 18 to 24 is, I'm giving it value 1. Then 25 to 34, 25 to 34, 25, 34. Then I give it value 2. In the old value, then I add. Then the next one should be 35 to 49, 35 to 49, 35 to 49, 35 to 49, 49. And I give it value 3. Sorry, there's one here which I think needs to be it should be 2. Okay. Okay, good. Then the other one should be 50 to 64. 50 to 64. 50 64 is 4. That is 4. And then lastly, over 64. Over 64, it is it's now not going to be range. It is value through highest. It is 65 onwards. I give it 5. Okay. Good. So what I will do here, so I have number 1, 2, 3, 4, 5. I will just click continue. And then I click OK. Where is my category called variable? What's my category variable? Here it is. Here it is. Then once you have it, you can now modify it, give it labels, give it like now I need only the decimal place. The label is 0, then value labels, I should now specify them here. That 1 is 18 to 24. 24. I add to 25, 34. Number 2 is 25, 34, 25 to 34. I add. Then number 3 is 35, 35 to 44, 49, I think so. 49. I add. 4 is 50 to 64. And add, and then number 5 is over 64. Over 64. Look at that. Then I run. So that if I save that, if I now go to data view, I can now see similar stuff. So if I run the analysis now for that particular variable, descriptive, and it is far at the end. Whenever you transform, it goes at the extreme end. But by the way, it should be ordinal. It should be ordinal. It should be ordinal. Then if I do analysis of that, frequency, age category, and then okay. This is what you get. It's similar to what we were having at the other time, right? This is what we are having. This is what we had previously. Are they not similar? Yes, they are similar. They are similar. So that is how to do transformation. So you don't necessarily need to ask a respondent, when were you born? What is your age? You know, those are the similar questions. SPSS can do that for you. Okay, now let's run briefly. I know time is really catching up with us, but it is good to get the concept also very right. We need to be advised by Doc here. Please keep me posted on the time in case time is over. Let me know. I can see we are less with 20 minutes. Graphics. I think I've mentioned how to deal with the numerical values and categorical values and so forth in frequencies. Frequency is very, very important for you. It tells you whether there is any missing values. It tells you whether there is any outliers. For example, if for example you have some awkward value entered in your data set, you can easily identify them in the frequencies. So for example, I entered 9 there. And then I ran town size and analyze town size. What happens? Geographic region. You see, it gives you. It did pick it. Sorry, it did not pick it. It did not pick it. Sorry. Okay. Sorry. It's town size, not geographic region. Analyze descriptive. Frequency. Analyze descriptive frequency, and then geographic town size. If I enter that, you can easily see that there was a value I entered 9. Already is giving some indication that there's a problem with this particular variable here. There's a value which is appearing, but it should not be appearing there. Are you seeing that? So one frequency table is going to identify for you any errors that are available in your data set, or any missing values available, account for missing values in your data set, and so forth. So running frequency tables is very, very important. And this, please researchers, does not mean that the whole of your thesis or the whole of your research report is full of frequency tables. Frequency tables is meant to give you an idea of what is being communicated in your data. I mean, in your data. Don't put the whole report with the frequency tables. This is just preliminary analysis. It just helps you to think what's coming next. Like this one is telling me I need to correct my data set. That's what it's telling me. Some people even put this one including the missing, the wrong data, wrong outliers. You say there was blah, 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 and an outlier 9. Why do you report outlier? Deal with the outlier. Don't report outlier. Deal with it. Yeah. So, yeah. So it is very, very important that you go now beyond the just frequency tables. Of course, I know there are some objectives that can be answered using frequency tables and basic graphs, but that basically is a very, very low-level research. For a master's research or a PhD research or a serious research, I do not think that just creating an objective that's going to be answered by just frequency tables is quite good. And of course, your supervisors will be advising you on this. Okay, so let's also see other exploration approaches, that is graphics, but yeah, graphics. So on graphics, you can use chart builder. I don't want this one to be shown again this time. Chart builder, it gives you options, the available graphs which are there. For example, I want to draw a graph for the geographic region. How was the respondents distributed? If I bring it here, I just drag it here. Oh, sorry, I specify the graph first. You have options of graph here, like geographic regions, sorry, is basically a categorical data, and the best graph for that is bar graph. That's why I was saying you must ensure that you use the graph that are I mean, in tandem with the kind of problem that you want. So bar graph is okay. So you see, I've just moved, I dragged the graph, the bar graph inside here, inside the sample graph preview window. Then I want to have just a single bar graph for geographic region. I take the variable from the variable list, I drag it into the x-axis here. And if you drag it there, remember the x-axis counts automatically counts. It is giving you counts. It's giving you counts automatically. But you can specify also from there. You can also make some properties. You can. There are some. If you click on counts, it gives you options. You know, you can select the properties and counts of. You can specify the counts of something, of respondents, and so forth. Yeah. So it is something that you can always graph appearance. You can always maneuver through those settings and see what happens. Okay. Then you say, okay. Yeah, just say, okay. And this is your graph that you're having. It's the graph which you're having. I always advise sometimes there are some software which are very good in doing graphs. There are some software which are very good in doing graphs. Once you have the frequency table, you can always as well export the frequency tables to those particular software and draw better graphs. Like for example, if you look at these graphs, to me, if you want to put this in your report, it doesn't really look nice. I don't even like the way it's appearing. And when you put it in, when you send it to your Word document, you can't even change these font styles unless you change them here in SPSS. But sometimes you want to, you are doing editing, you brought in your graphs already, you're doing editing in Word, but you need to make some changes on the how the graph appears in terms of fonts, font style, font size, and so forth. You can't make that corrections. And this is what I always advise. Once you have your output in frequency tables, you can export that to Excel, something like that. Excel is a very good grapher. It can do a very good graphing for you than the graphs that you get in SPSS, by the way. And then you can easily manipulate those graphs easily and so forth. So always you can go about around that and see which one is working out for you, and then maybe you can make a decision on that. But of course, if you are still sticking on the graphs for SPSS, fine, well and good. But those are some of the disadvantages you'll be getting when you export them to one document. The other graph that you can think about is, for example, gender. I want to do the graph of gender. I do reset, and I want gender can easily be seen in pie chart. Pie chart is used when you only have one variable to be represented. So if this is my pie chart, I can bring in gender here, slice by gender. So you can easily see that. If I say okay, you can see already male almost 50-50, almost 50-50. You know, such kind of graphs can be very, very handy when you are running your analysis. Now, there is one important one that we didn't get very nice frequency tables out of, and we may want to run exploration on it. That was age. Remember when we ran the frequency table for age, we got a very long table which was not even making sense to us, and therefore, how do we do exploration analysis on it? Instead of going through categorizing it, is when we run it. We might want to just run age the way it is. What kind of graph are you likely to run in it, for example? So age is here, and graphs. For such continuous data, you always need to run histograms, for example. Sorry. Chart builder. Reset. Histograms. Histograms are good for numeric data, so I'll use histograms. Remember, histograms is different from bar graphs. Histograms are different from bar graphs. If you look at bar graphs, look at histograms. Histograms, all the bars are attached to each other, but bar graph, the bars are having some spaces between them. That's the difference, and those spaces are meaningful. Don't just ignore them. So histograms are not the same as bar graphs, right? So I'll use histograms here, and then age. I want age to appear here. So when I say okay, this is how my age is appearing. So already it's telling me that my age is not following, because for numerical data, what you are aiming at distribution which is normal, because most of the techniques in statistics, most of the statistical techniques require that you have a normal distribution, and they assume that. So that's what we are looking for. Once you have gotten age is not normal here, you start to think now, what next? How can I use this particular variable? And that's what is calling for the categorizing and so forth. But if it is normal, then it makes work easier for you. You can now start thinking of some better models using the variable age. Otherwise, as it stands now, it's not normal. Normal is a bell-shaped thing. It looks like a bell. You know, that bell that you use in high school to inform teachers that your lesson is over. That small bell, that's bell-shaped. They always look like that. That's what we call a normal curve. So that normality is always very important for any numeric variable. If you don't attain normality, then it needs you now to start thinking, what next from there? Do I need to do categorization? Do I need to normalize this one? And so forth. And of course, there are so many ways of doing that. You can normalize or transform it to other variable to give a normal numeric or to categorization. Okay. Okay, so graphics here, you can play around with it, and there are so many other options that you can think about. So many other options. Let me explain about box plots. Box plots also are very important in presenting numerical data. Box plots. So let me just use the same data set, age in years, but draw box plot. And I explain box plot, then I move to the other things. Let me reset this one. Box plot, and I need this one here. In the x-axis, I need age. Okay, so if I say okay, so that is what box plot is looking like. It's almost it tells you that the distribution is within 1860, and of course there are some values which are appearing. So this box plot has got five things that you must understand. Number one, the minimum value, the lowest value here, this line here, is the minimum value, and then the maximum value, and then the median value, and then the distance. I mean the first quartile. First quartile is the age of this box here, this lower age here. This lower age here is very, very important, and this lower age. So, and almost actually, when you are looking at the previous histogram, it didn't look normal, but when you look at the box plot, it portrays some normality. It portrays some normality, because for you to get a normal scenario, the distance between minimum and quartile 1 must be the same distance between quartile 1 and medium. This distance here. And should be the same distance between median and quartile 3, and same distance between quartile 3 and maximum. And as from the look of things, sorry, what did I do? From the look of things, you are seeing almost all those distances are almost equal. So it really portrays some aspect of normality. Somebody can easily carry away normality assumption in this particular variable, age in years. But again, when I look at it in the histograms, it didn't really depict normality, but that's now where the controversial discussion starts. Do we now assume normality here or not? Then you end up now going for further statistical test for normality. You may now need to test whether this normality, is it really existing or not? So this is what is called a box plot. Whenever you get this kind of a box plot, this is a good shaped box plot. This is a good shaped box plot. I don't know how number of years in education could look like. Let me just have a look at it, because I need to give you another box plot, which is not a good one, and any analyst will not want to see. Let me just drag this one here again, and then the years in education. I put it here. I see what happens. Look at that. This is also fairly a good box plot anyway. I'm not seeing one which is very bad. It's also fairly a good plot, because it is almost in the middle. The blue part is the middle. The lines up and the lines down are almost equal in length, and therefore that is also not a very good one. But this one was employment something, years of current employer. Yes, this one might give us something. Let me see. This one here, chart builder, reset, years with the current employer. It must be this one here, current employer. Okay, this one here. Let me just put this one here. Okay, what's happening there? Okay, I don't know, it's not, okay, reset. Yes. Oh, it is not numeric. It's not numeric, so that's why it's not accepting. It's not numeric. Okay, household income. Household income, maybe it might give us something better. Good. Look at this box plot now. This is a very, very bad box plot. Very bad box plot because of the if you look at the line, the top line, there are so many other points on top of it, which portrays some outliers. If you remove these outliers, most likely you might end up with a better box plot. So these are some of the things that can help you understand whether a variable is really in a good shape or in a bad shape. Okay. Okay, so I'm not very sure, Doctor. I'm seeing I'm left with 2 minutes. And yes, as you can see, we are yet to even get to a quarter way of this. I don't know what's your take. Maybe you can advise. Over to you. Thank you.
I'm not sure if people will be available, but I think we can have 30 minutes more so that you can finish what you needed to.
Okay.
But I also think maybe there are people with questions. If you can give time for people with questions.
Can we take, I'm thinking this way, can we take questions and then I can make some videos, then they can follow in my YouTube channel.
Okay, that's also fine.
Yeah.
I can already see a hand or.
Yeah, just let them in because I can't see the hands from my side because I'm the one showing my screen.
Okay. I can't also see who's this. Let me just do something here. Okay, can you please, I saw a hand, just come through, please. Jimmy
Morning, Doc.
Morning.
Yes, I have a question on what you said about exporting the graphs. Yeah, so you mentioned earlier on that because the graphs in this SPSS may not be looking good enough, so there is a way to export them when you have the frequency tables. So my question is based on, for example, if I want to export them to Excel, should I export the frequency tables or the entire data before I even run the frequency tables for me to do better graphs from Excel? Will Excel give me access to such things as box plots and also the other types of graphs that I can make use of? And will it be able to do the analysis in the same way as what SPSS is able to do? Yeah, so my question is based on what kind of data then do we export to Excel for us to have better graphs? Is it the frequency tables or before even the frequency tables are made?
Okay.
Yes.
Please, Doc, can I just respond them as they come in?
Yes.
Okay, great. Yes, SPSS is helping you to summarize your data. You don't export the data set, you export the summaries, like this one here on my screen. This is a summary, frequency summary for age category. I'll just copy it there like that. Just as simple as normal copying. I come to Excel and then I paste it here. Remember, this is my variables that I want to run the graphs for here. Okay, so here I'm talking of age category here, and here I'm talking of the frequencies here. Okay, so if I highlight this and go to insert graphs, For example, I need these graphs here, this graph here, bar graphs here. You see now like that one?
Yes.
It looks very nice, and you can change all these things. You take this one to Word, it looks better than the graph that you are seeing in SPSS.
Yes.
Yeah. So this is what I was saying.
Okay.
Thank you.
Any other question? Okay, I don't see any questions. Please, I think you can proceed.
Okay, thank you. So yes, so let us see if we can do something again for the next 30 minutes to see if somebody can get something from this. I want us to look at now deeper next level of analysis. Remember, up to what we have done is basically descriptive analysis, just looking at what your data is communicating and so forth. Somebody can have a question in his research. One of the such questions could be, is there any relationship between gender and the years spent in education, for example? Is there any relationship between gender and years spent in education, for example? But before I get to that one, let me get a different scenario. Gender and job category. Is there any relationship between gender and job category? Remember, gender in this case, we are talking of male, female. It's a nominal kind of data. And job category here is also nominal. It's also in category. Managerial is either managerial, sales, blah, blah, blah. We want to find out which particular gender dominates which particular job category. Now, these are now the kind of questions which should emanate from your research questions or research objectives and so forth. And you are out to find out some kind of relationship if they're there. Okay. Now there are two levels of answering this question. Number one is the frequency at the frequency level. How many particular gender are falling on a particular job group? And is there any statistical relationship between those two variables? Remember, I'm talking about gender and the job category here. So let's start with the frequencies of the two, running the frequency of gender and the job category. Okay, so if you want to do that, just click Analyze. Then there is a place for descriptive statistics. Then we have cross tabulation. Cross tabulation is going to be used to categorize between, cross tab between the two variables, or 3 or 4, depending on how many you have put. Now in the rows, I want job categories. Job categories to go there. And then in the columns, I want gender to go there. I'm not touching any. I'm leaving it default. All the setting as default. I'm just running it as default. And this is what I'm getting if I run it without touching any statistical things. So you get this information and say, from the look of things, when you look at which gender is dominating, or which job category is dominated by which gender, for example. Actually, if you look at managerial and professional category, female gender is more compared to male gender. That's one you can see. Again, if you look at sales and office, you will still find female is dominating. Service, female is dominating. Agricultural and natural resources, female is dominating. Precision production, craft and repair, male is dominating. And operations, fabrications, female is dominating. Now, just from the glimpse of that particular result you are seeing, there is also an information that is communicated by total. Look at total. Males are many, females are few. I mean, no, males are few, females are many. I mean, are more than male. So could this result, remember, if that total, you find that information that one gender is more than the other, could that be the cause of the fact that female is dominating in all those other categories which we are seeing? So we can't just conclude in blanket and say that female are dominating male in managerial and professional. Female are dominating male in sales and office and so forth. You can't have that blanket I mean, interpretation. There is a very important part that total is playing. This could be as a result that female were more compared to male in this particular survey here, and therefore we can't really say that female is dominating, is the dominating gender in these categories. And therefore you now start thinking now, what do I do from here? Is it true now? It means what I'm seeing is not true. What I'm seeing may be true or may not be true based on what I've just explained on the total. Go ahead and think of some other thing. This is now where you call in to do a chi-square test if there is any relationship between male and female, male, female on job categories, if there is any association. Okay. So if I go back and answer that question, I will redo the cross tabulation, but this time I'm going to state the statistics. I need chi-square. Yeah, for now, that one. And then I say continue. That's okay. Is it okay? Okay. So you look at this chi-square test. At least now, when you specify the test statistics, both two tables come. The first table, we have the cross tabulation. The second table, we have the chi-square test. Now, the cross tabulation is what we were seeing the previous one, but now in addition, we are having chi-square test. What does chi-square test tell us, and what are we looking at? If you look at the chi-square test, there's that first row, which talks about Pearson chi-square test. Now, that Pearson chi-square test, there is that last column which talks about, which says the asymptotic significance. That asymptotic significance is a value that should range between 0 and 1. It is actually what we call the p-value. Remember, for those who are in the first session of this seminar, I mentioned about p-value. Now, that p-value is very, very significant whenever you are interpreting whether gender is having any association with job category. You make use of that p-value. Now, I want just to write some things maybe in for you to just to refresh your statistics a bit. There's what's known as the test statistics, or the hypothesis test. In a hypothesis test, whenever you are testing, you must understand what are the hypotheses that you are testing, H0 and H1. For chi-square tests, we have for chi-square test, we have H0. What we are testing H0 is that there is association and there is no association. sorry, it's vice versa. It should be no association and there is association. Sorry. Should be vice versa. Should be vice versa. This is no association. And there is association. Good. So let's get back to our chi-square test that we are having here. This chi-square test is telling us that we have a p-value of 0.83. .838. Now, how do we now end up rejecting or not rejecting the H naught? If p-value is more than alpha, we reject the H naught. Is less than, reject the H naught. Otherwise, we fail to reject. So what should always look at is p-value. Is it less than alpha or not? If p-value is less than alpha, we reject the H naught. Now, what is alpha? Remember, I mentioned this in the last presentation. Alpha is the level of significance. Level of significance. Now, in most cases for social research, we always use 5%. A more precise research, we use 1% or 10%. So assuming you use any of these, actually 10% is 0.1, 1% is 0.01, 5% is 0.05. Assuming you use even any of these, and you consider it with this p-value here, this p-value is more than 0.1, which is 10%. Is more than 0.01. Is more than 0.05. So regardless of any possible p-value that you take, the p-value, any alpha that you take, the p-value is still more, more than that alpha that you are taking. And therefore, in this case, in this particular problem here, we are going to reject the H naught. We fail to reject the H naught because p-value is more than alpha. Because if it is more than alpha, we fail to reject. And if we fail to reject, it means we conclude that there is no association. Now, what do we conclude there? Our conclusion in this particular problem is that there is no enough evidence to reject the H naught. Hence, we conclude that gender has no association with job category. So it means what you are seeing in the table, or the first table, does not really make statistical sense. They are just numbers, because the test is telling us that as much as the frequencies are varying from each other on each cell, there is really no, we cannot put our fingers there and say that those numbers make any statistical differences between different genders and job categories. So any person, any gender can be in any job category in equally likely situation. Okay, that's what we call chi-square test. So whenever you are doing cross tabulation, you need to start thinking of chi-square test. You need to start thinking of chi-square test. Okay, good. So the next thing that I'm going to show you are t-tests. Assume one of your questions that you are asking in your research is that let me take one very common variable. Which variable is this? Income. Assuming in one of your questions you want to find out the level of income, and one of the objectives you want to find out the level of income of your respondents in this survey, and you have a question that says that the mean level of income is $50 per week, for example. That is your what? That is your assumption. Your hypothesis, and the question that you want to find out you want to find out if this is actually true or false. So your research want to find out if the average income for the respondents in this survey is actually 50 or not. So in that particular objective or hypothesis, you will use what's known as a t-test, and it's going to be called one sample t-test because you are trying one variable against a specific value, which is 50 in this case. So before you do that analysis, it is important to run descriptive analysis of that particular variable, which is income. Okay, so the analysis will be descriptive analysis for income. Household income. Okay. So from this income, we are seeing the minimum value is 9. The maximum value is 1073. That is the average income per week in dollars. And mean is 55. Standard deviation is 55. Is it true that this mean is actually 55 based on statistical tests? Or, is it 50 based on statistical tests? Or is beyond 50? So again, let me refresh your statistics. I think I will need a bigger page so that I can write. Let me refresh your statistics again. So we are going to look at one sample t-test. And the such question is that the mean or the average household income is 50. So it means the hypothesis would be H0, H1, household income is 50. H1, household income is not 50. And by the way, this one gives you an indication on how to write your question. Remember, I've posted this question based on hypothesis. This is hypothesis statement. It's not really a question. So based on the way you make your hypothesis, you can easily now come with your question. The question that you can come up with from this particular hypothesis, based on the way I've stated my hypothesis there, would be has the household income changed from 50? This one, it goes in tandem with the way I've defined my hypothesis there. Changed here could be less or more, remember, okay? So if I want to test this hypothesis now, or to answer this question, this table alone cannot answer this question. This question can only be answered by one sample t-test. Okay, so how do you run that one? Analyze. You use compare means, and then under compare means, you click on one sample t-test. And then we are talking of household income. Household income. And then we are testing against which value? You remember there's this statement here, test value should be 50, testing against 50. And then, okay. If you run that, as well, we'll end up with you will end up with some tables. The first table that we are ending up with, the descriptive analysis that we had before. I think that one we had before. And then if you look at this value here, this table here for t-test, one sample t-test, the first table is almost similar to the table that we had for descriptive. So it runs for you also for the descriptive, where you get your mean and standard deviation. And then the second table, which is the most important table, is t-test. The t-test results. In the t-test results, we have first column, the t-statistics, which is 6.417. We have degree of freedom, which is 4999. And then we have the p-value. The p-value both for one-sided and two-sided. I think I will explain that one in this platform. But for both of them, it is less than 0.01. P-value here is less than 0.0. So it means it's so small than 1%. It could be 0.01% or something. That's why we use less than 0.01. So if, as I mentioned, this p-value is what is very, very important here. Is what is very, very important here. If I pick 0.01 and then I take you back to the statistics again. Yes, our p-value here is saying 0.0 less than 0.01. And our alpha, remember, it should be 0.01, 0.1, and 0.05, 8 of them. So it means in this case, our p-value is less than alpha. Is it? From our table there. Because p-value is some value which is very, very small, less than 0.01. So it means it's less than 0.01, less than 0.1, less than 0.05. And if that is the case, if p-value is less than is less than alpha, then we reject. We reject H naught. And what are we rejecting? We are rejecting that household income is 50. So we are rejecting this one, but we are taking household income has changed. And therefore, this answers the question. There is enough evidence to ascertain that household income has changed from $50 based on this information that we have gotten here. Okay. Now, in this result here again, you saw I told you I promised to mention something about one-sided P or two-sided P. Actually, what we have run here is a two-sided P. It's a two-sided P. You can also have a one-sided P based on your question. Remember, our question here, has the household income changed? Changed here could be less than 50 or more than 50. That gives you a two-sided rejection rule. So you reject if it is less, or you reject if it is more. Now, you can as well define your question as, this is the first scenario. Second scenario could be, has the household income increased from 50? Has the household income increased from? These are two different such questions. Remember, the first one was saying, has the household changed from 50? Changed here, it is increased or decreased. But the second question there is asking, has the household income increased from 50? Okay. Now, how will we design the hypothesis? Hypothesis number one would be H naught mu would be less than or equals to, more than or equals to 50. For the question, it should be less than, sorry. Yes, because that is the alternative hypothesis. There is such a hypothesis. Without that one. So if it is increased means H naught, H1, H1, sorry, my pen is having a problem. H1 mean is more than 50. Always that question that you are having, peg it on the H1. Then H naught becomes mean is less than or equals to 50. That is how the hypothesis for that question looks like. The third scenario question that you can ask there. So this one here is called a one-tailed, one sample t-test. This one is one-tailed. The other scenario could be, another question could be, question number 3 could be, question number 3 could be, has the household income decreased from 50? Now, how will be the hypothesis? We have H naught and we have H1. Mu decreased is less than 50, and then this is more than or equals to 50. So this one is also a one-tailed test. It is one-sided test. So the first one, which we started in blue, is two-tailed test. The second one in red is one-tailed test, and the third one also is a one-tailed test. And they correspond to the particular questions which you are asking. Remember that. So when it's a one-tailed test, then you make use of the one-tailed p-value. When it's a two-tailed test, then you make a reference to a two-sided p-value. Okay. Doc, what time is? I think is up. Over to you.
Yeah, the time is up. Was that the last one?
No. That cannot be the last one. We have just done. We are now almost at slightly more than a quarter. But anyway, the rest can be followed later.
We have another seminar this afternoon.
Yes, please.
So maybe I'll try to organize some other time so that you can complete and also talk about. I feel like regression will be more important as well for our PhD students because I think at a PhD level will be required to do that kind of statistics. So probably we can organize another time if you are available. To give another talk because now it's 11:31. I'm sure people are also a bit exhausted.
That's true.
Yeah, so let's try to organize some other time. I'll come back to you and see the best time that you can complete. And yeah.
Okay.
I think that's fine. So are there any questions from people? Okay, looks like there are no questions. I think people are tired.
I think so.
Yeah. So thank you very much, Dr. Ongala, for this powerful presentation. We always appreciate your support in our program, and we are looking forward to a follow-up presentation on quantitative data analysis.
Yeah.
Yeah, so just for those who are online, we have another seminar this afternoon at 2. From 2 to 4, it's going to be on, it's practical as well, just like this one. It's going to be practical on Mendeley. Those ones who wants to learn how to use Mendeley in their referencing citation, it will be a good opportunity for you to join us this afternoon. I can see one hand online. Hoffin, Lavinia, please come through.
Oh, good morning. Thank you so much. Dr. Ongara mentioned something about a YouTube channel. I just wanted to ask if you could maybe give us the details where we can find him on YouTube. Thank you.
Okay.
Thank you.
I'm going to post
Yeah,
my
just
YouTube
put it
channel.
in the chat.
Yeah.
Yeah, so that everyone can follow.
Yeah. And again, there is a question that I've just seen on the chat, Doc.
Okay.
About contingency table. Somebody was asking, can I present a contingency table? Actually, my last presentation, my second last presentation on cross tabulation, that is a contingency table. That is the contingency table I was presenting.
Yeah.
Thank you.
Yeah. Okay, so in that case, have you already put your YouTube channel on the chat?
I'm just posting it right now.
Okay.
Then they'll get it.
Yeah. So you can get it, you can follow him on YouTube and then I think get the details from there. I think there are a lot of I haven't followed him, so I don't know what content is there. So please just go there and see what you can get.
Okay.
Yeah.
Let me post it there. I'll post it there. Okay.
Okay.
Thank you.
So I think everyone will be able to see it. Yeah, I can see it now. So you can follow him and yeah, and that will be helpful for you. So thank you very much and thank you everybody who has followed us from the beginning. I can see a lot of people who have been following us, joining our seminar from the beginning till now. We appreciate your support. This is actually good for everyone. I would advise those who have friends to always join these seminars, especially those who are doing PhD by research or even masters by research. It helps you as you develop your proposals, as you analyze your data. So please join us this afternoon if you are interested in the Mendeley software for citation and referencing. So have a good afternoon. See you at 2 o'clock.
Thank you.
Bye.
Bye.
Thank you so much. Bye-bye.
Thank you. Bye.